Bismillahirrahmanirrahim. In the name of God. Hello students, I hope you will be okay. We want to speak about VHDL and a brief introduction into VHDL and its application. Then this lecture is about an introduction to VHDL. And at first we must know that why we need VHDL or VHDL. We know that our digital systems today are very complex. Maybe 50 years ago, the digital systems were simple, but after some years, the digital systems begin to be more and more complex. This complexity caused that that modeling and testing this or these digital systems will be difficult. Maybe in many years ago, testing and modeling of digital system could be done by experimental facilities, but today's we can model and test digital systems only by a processing machine like computer. Then this need to model a complex digital system and this need to test this digital or many digital system, many complex, complicated digital systems cause the engineers to design a special language, really a computer language. This language describes the hardware, the system, the digital system. Then in this language we have hardware description language like this. Then we need to HDL for modeling and testing the digital systems. We have two kinds of HDL. One of them is academic language. We call it VHDL. VHDL is the abbreviation of Very High-Speed Integrated Circuits Hardware Description Language. And the other is Verilog, and it is an industrial language for industrial environments and some companies. But both of them are very famous and regular. And now we select VHDL for modeling, for description, and for testing digital systems. After this step, we can go to other slide. That this slide is speaking about algorithm implementation. You have an idea in your mind and you want to implement it on a system. You have different solutions. One of them is software implementation. In software implementation, you use from a computer language. You use computer language and you implement this algorithm into computer. This method has some advantages and also some disadvantages. Advantages of this method is its flexibility and its easiness, because writing in computer language or for algorithm implementation can be very easy for many users, and this language or this code, this program can be changed with respect to the user requirements, and then this method of implementation can be flexible and easy. But as you know, because we select computer as a system for implementation, then this method is not optimized from a speed and power consumption points of view. The other method for algorithm implementation is hardware implementation. It means that we implement this algorithm by designing an IC, an integrated circuit, specifically for this kind of algorithm. This method has some advantages and disadvantages too. The advantages of this method is its speed and power consumption. This method is a very optimized method, and the speed of this method is very high, and the power consumption is very low. But in the opposite point of view, this method has some disadvantages. The flexibility and easiness are removed because designing an IC is a very complex process. Then this is not a very easy method, and changing an IC really is impossible. The other method of implementation is microcontroller implementation, and this method has a medium range of flexibility and speed and power and easiness. Then it has a medium method of implementation from flexibility and optimization, I mean speed and power optimization points of view. And the last method that we want to introduce you is Fpga implementation. It means that you need to, something like language, which select this language, you write the code of this system or the description of this system, and you program the Fpga. Fpga is a platform that you can implement any logic function or any algorithm on it. Then by Fpga implementation, you have a medium range of flexibility, a good range of speed, and a medium range of power consumption, and it has a medium range from easiness point of view. But Fpga has a very special facility. It is very proper for parallel computing. Parallel computing, it means that you have or you can have many processing elements that work in parallel with each other. Then this method of implementation is very good for a high velocity of processing, a high amount of processing. For example, in image processing, in heavy amount of coding, in heavy amount of processing for signal processing like radar processing, real-time processing. in some other things like neural network implementation or any other